Welcome to machine learning tutorial. So today's topic is data preprocessing. As you know that the basic requirement of machine learning is data. We collect our data set according to our problem and then perform some machine learning algorithms on our data set to predict our output. So after collecting the data set, next step is data preprocessing. Data preprocessing is done to improve the quality of data. Like if we collect the data for our problem, then the data may have some noise, inconsistency, duplicacy, or maybe it may have outliers or features that less contribute to our output. So there is a need to pre-process our data to make it clean, to scale it, to transform it so that it can become machine readable, or we can say it becomes suitable, the data becomes suitable to apply machine learning algorithms easily. The very first step is to import libraries using Jupyter Notebook here. So the first step is to import the libraries. Import numpy as np. NumPy is a module for Python which provides high-performance multi-dimensional array object and tools for working with these arrays. Import pandas as ed. Pandas is a high-level data manipulation tool used for data analysis and Python as plt. So after importing libraries, next step is import the dataset on which we are going to perform our data preprocessing. I'm using loan dataset which is available on Kaggle. So I will import my dataset here. It's here. This is the path of my dataset. These are the columns present in the dataset: loan ID, gender, married, dependents, education, self-employed, and this the shape of dataset: 614 rows and 13 columns. This is the first 5 entries of my dataset: loan ID, having these values: gender, married, dependents, education. So this is my dataset, and we have to predict loan status. This is our output. We have to perform operations on these features. We have to use these features, and using these we have to predict the loan status. So after importing dataset, next is handling missing values. This is the most common problem we face. First of all, we try to look whether there is any missing value present in our dataset. If present, then we can drop them. We can drop rows which have missing value, or we can drop the entire column. In order to maintain size of data, it is preferred to fill the missing values. Like when you are having missing values of numerical data, you can easily fill it by using median or mean, or by maximum or minimum value, or by average of neighbor elements. So we can easily do this, but the situation is different when we have missing value in categorical data. So it's not possible to fill the values with the median mode. So in this we can replace the missing value with the ones which are occurred more, or we can take help of machine learning algorithms to predict value. For if we have large data set, then we can simply drop the missing value. But if we have large, but if we have small data set, then it is preferred to fill the missing values. So we will try to look for the missing values present in our data set. How many missing values are there in our data set? So we have 13 missing rows in gender column, 3 in married, 15 in dependents, and these. So we will simply remove this. Now we'll check size of our data set. It's 480 rows and 13 columns. In starting, we were having 614 rows. So we have dropped the rows which are having missing values. So after handling missing value, next is dealing with outlier. Outlier is nothing but an entry in the dataset that is different from other entries, that may be either very small or very large, or we can say it's an abnormal value in our dataset. So we have to remove these outliers. For example, like this, we are having this dataset. In this, we have one column that is name of person and other age. In this, we can see that ages of person are given here, like 39, 935, 48. We can see that it's an we can say that 900 is we can see 900 is an outlier here, like because it is different from other values, or generally 900 is not an age of a person, so we can call it as outlier. So we have to remove the outlier because the presence of outlier in dataset may decrease the can decrease the accuracy of our model. But it is not always preferred to remove the outlier. Sometimes they can influence your dataset. So we can keep them if they show some important information. So before removing outliers, you must think whether to drop it or not. Drop when? Drop the outlier when you know it's wrong, when you have a lot of data set. But if you are having small data set, then obviously you have to replace the outlier value with a valid value. But before removing outliers, It's obvious that we must know whether the outlier is present in our dataset or not. We have to detect the presence of outlier. Like in this example, we did it manually, but when we have large data set, we cannot do it like this. So in order to detect the outliers in our data set, we have a lot of methods. Like we can detect the outliers present in our data set with the visualization tools, and there are all and there are other techniques also, like box plot diagram. As first we calculate the lower quartile. First we calculate the lower quartile, that is median of lower half of data set, and then upper quartile, whose and upper quartile, that is median of upper half of data set. And then using the value of lower quartile and upper quartile, we calculate interquartile range, which is equal to upper quartile minus lower quartile. And using this IQR value, we we get lower limit and upper limit values in a dataset that are not present within this limit. That means they are outliers in our datasets. After the detection of outliers, we can easily remove them. We have a lot of other techniques also to detect the outliers, and other we also have duplicacy in data set, noise, inconsistency in data. So we have to remove all this in order to prepare the data. So next we have to perform some transformations on our data. Next we have to perform some transformations on our data. As you know that the data which we have is not present, it's not always present in right format. So we have to transform the data to make it more useful, to make it suitable to apply machine learning algorithms on that. So we transform our data. Like in case of categorical values, we change them to numerical values, and in case of skewed data, we perform some logarithmic transformation. So there are many other transformation activities that depends on the type of data. So how to deal with categorical values? We have to convert the categorical value into numerical value, because as in algorithms works better, because as you know that machine learning algorithms works better with numerical data. So we have to convert categorical data into numerical to make it machine understandable, so that we can apply machine learning algorithms on our dataset easily. So I will discuss two methods, one hot encoding and label encoding. So let's first discuss label encoding. Label encoding, we just simply convert the categorical data into numerical. Like we have this color feature which is having red, blue, green values, and the speed feature which we have categorical values like low, medium, high. So we simply convert them into numerical value. Like we replace red with 0, green with 1, blue with 2. So wherever these values present, we will convert them to numerical value. Like whenever red, so whenever red comes, we will replace that with 0, so and so on. Similarly, similarly with speed, we will replace low with 0, medium with 1, and high with 2. So, so we just simply convert the categorical data into numerical. There is a problem in label encoding. That label encoding assumes higher the categorical value, better the category. Like if we replace anything with higher value, then the corresponding categorical value, then it shows that the corresponding categorical value is better than the previous categorical value. Before discussing it, let me first introduce the types of categorical variable. So two types. First is ordinal data. Ordinal data means the data which have quantitative value. For example, we are having the speed feature. It's having three type of values: low, medium, and high. Like value of low is less than high, so we represent low with 0, medium with 1, and high with 2. So high the categorical value, better the category is. And next type of categorical variable is nominal. Nominal data is a categorical value that have no quantitative value. For example, in this colors feature, we have three type of values: red, green, blue. But we can't compare red with green, green with blue, like we compared in case of speed. So as I told you before that label encoding assumes higher the categorical data, better the category. So in case of nominal data, it is not preferred to use label encoding. So before encoding your categorical value, first check the type. So next we use one hot encoding to convert our categorical values into numerical ones. So what happens is like we are having this feature, color feature, having values red, green, and blue. So we have to convert them into numerical value. So one hot encoding represents categorical variables as binary vectors. First step is to map the categorical values to integer values. Then each integer is represented as binary vector. That is all zero values except the index of integer. That is marked with 1. So for example, we will one hot encode this color. So we are having this in which 0 indicates the absence and 1 indicates the presence. So whenever a value, categorical value is present, then we will mark the corresponding row of that column with 1. So in this way we will one out encode our categorical features. So let's take an example. Let's one out encode the categorical features that are present in our dataset. Like we are having this gender column, married column, education column, self-employed column. Categorical values are present in this, so we have to convert them into numerical values. So we will one hot encode this. So one method of one hot encoding the categorical values is to use the dummy values. Before converting this, let me divide our data set into two parts. As X X is the input features and y is the output. Means using these x values by applying machine learning by applying by training our model on these x, we can predict the value of y. So y is nothing but the output. That is the last column. So now we have to one more encode our data set because it is having categorical values. We are having this x. Now we have to one hot encode the categorical features like gender, married, education. So let's do this using dummy values. Dummies. This for what? For like first we will take this gender column. Now we will print our dummy table. So now this is our dummy table in which, as I have told you before, that 0 represents absence and 1 represents the presence of that particular category. So like this in our gender column, first entries of male. So the male column is represented with 1 and corresponding row of female column is represented with 0 there, which shows the absence of female and 1 shows the existence and presence of male. So now we have one hot encoded our gender column. We have converted a gender column to numerical. So we have converted this categorical gender column to numerical one. So now we will join this dummy table with our data set. So we got new data set. We have one hot encoded is our gender column. Now it's of no use because we are having a non-numerical value, so we can just drop this column. We will drop this column gender. Now let's see our new data. So now let's see our new data set. Now we are not having gender column, but numerical. Now we are not having that gender column. So similarly, we in this. So similarly, we will one hot encode this married column, education column, self-employed column using same procedure. That's by using dummy values. PD dot. So the so the columns which we have to one hot encode are married one, education. Next is self-employed. What is property area? So we will just get the dummy table for these features. Now, after obtaining this dummy table, we have to join this into our dataset. So our new dataset is this. We have joined our dummy table, and as you know that these columns are of no use, so we will simply drop this. So we'll simply drop these columns. So Maverick education, self-employed, and one was the property area. Yeah. So just to drop these after dropping. This is our new. So after dropping these columns, we get this. Now our data set is free from categorical values, as you can see. So we can say that we have one hot encoded, or we have converted our categorical values into numerical values. Now, so next step is feature selection, which we have to select those features which affects your output most, which contribute to your output most. You can do it manually, or you can select the features using the, or you can do it manually, or visually you can select which feature is having more importance, which is having less, so you can just leave the features that are contributing less to output. Relevant features in our dataset can reduce or can decrease the accuracy of our model. So we just try to minimize the dimension of our dataset. We just consider the features which affects output more. Just working with all the provided dataset can lead to reduced efficiency, because working with all the provided dataset can lead to reduced efficiency of our model. Because if we consider the features that contributed less to the output, surely that will decrease the accuracy of our model. So that's why feature selection is important. There are a lot of feature selection methods. Like, like one is feature importance, one is correlation matrix with heat map. So let's discuss feature importance method for selecting the features. So let's discuss the feature importance method to select the features. But before this, let me drop this column because it's not contributing to output, because the every row is having unique loan ID. So there is no such relation of this column with other input columns and output columns. So we can just remove this. So let's do simply. So now our data set is. So this way we have to select the most contributing features. So let's discuss feature more one more. So let's discuss feature selection method as feature importance, which we will compare every feature, means we will compare which feature is contributing more towards our output. So let's discuss feature. So let's discuss. So let's discuss feature importance method. So first of all, we have to go to library. Strings. Now, so now we will write the input and output columns in our model. Oh, uh, couldn't convert string to float. This. Okay, so we are having this 3 plus value here in dependence column. So we have to simply so so we have just to simply solve this issue. So this is what really data preprocessing is. Why we do data preprocessing, like in this method it became a problem. Similarly in other models. So similarly in case of other models, we get a lot of errors like this. So we have to refine our data according to need of our model. So let's first do this. So, so now we will simply replace this 3 plus with 3 independence column, or you can do according to your choice what you feel is right depending on your data set. So now we had replaced every 3 plus with 3. So now we can so now we can do so now we can move further with this feature importance method to which will provide us which will provide us the most contributing features towards your which will provide us most contributing features towards our output. And we will use inbuilt class that is feature importances of this tree-based classifier. Using this feature importance, we will compare each and every feature contribution. We will compare the contribution of each and every feature towards output. So, importances, feature importance is now we will now using this feature importance, we will obtain now using this feature importance, we will obtain the contribution of each and every features towards output. We can simply analyze the contribution of each column for features. So that we can easily do feature selection, we will just select the features which contribute more to our output. I'm using 21 here because we are having no 17. We're having 17 columns, so this is 17, 20, 29. So we'll compare these 17 features, their contribution towards output. We'll plot the bar graph of this. We'll plot horizontal bar graph. So let's see what else. Okay, this is a graph. You can see credit history contributes more, and then loan amount, core applicant income dependence, and these are the other features contributions. So I'm not dropping any feature in this. And you can drop the feature or you can select the feature using this feature importance method depending upon the contribution of each feature. next step we usually follow is normalization. As you know that every feature in the dataset is having different ranges, so it becomes as so it becomes a necessary step. This range of data varies widely, so we just limit range of variables so that they can be compared easily. So we scale features to same scale, or we normalize features because input features have large difference between their ranges, and these differences can affect the machine learning algorithms and the model accuracy. So we have to normalize our data before. So that's why we have to normalize our data. So we have a lot of techniques to normalize our data. Uh, like we have Z-score normalization, so that the every feature value comes to same scale, uh, comes to same range, so that their comparison becomes easy. After Z-score normalization, range of values. So we limit the range of values, that is from -3 to 3. That is minimum maximum normalization, which we just normalize our data using the minimum and the maximum values of that particular feature. So in minimum maximum normalization, we limit range of our values to -1 to +1. So now let's perform normalization on our data set. This we are having um, this we are because there is a need to standardize our data, as we are having variations in the ranges of our values. So well, this normalization on data set. We are using Z-score normalization. Standard scalar. So now we have normalized our data. This. Now let's split our dataset into train and test set. So let's first of all do this one. Selection import train test set. Now we will split our dataset into train and test set. Train X is the input features that we are going to use in a training set. And test X is the input features of our test set. Again, train Y are the output feature, the output of our test set. Oh, sorry, of our training set. And test Y is output of our test set. So we will split our data set in this two sets, train and test set, with the test size. We generally use test size of 0.2, means test size is equal to 0.2, means 80% of dataset is used as training set and 20% is used as test set. So you can uh, take value of test size according to your choice. So now we had split our dataset into training and test set. So now we can say that we had pre-processed or we have pre-processed our data. We have prepared our data. Now our data is ready for model training. We can apply machine learning algorithms on our data set. Our data is ready. We had refined our data set. But again, I'm saying that I had discussed some of the data pre-processing techniques. These are not just enough. There are a lot of pre-processing techniques. So I was just wanting to give. So I had just given a brief overview of about what really data pre-processing is, how we do data pre-processing, what are the basic steps. So that's all in today's tutorial. Bye. Thank you.